Subscribe to the channel so you don't miss out on any of these videos. Imagine this: you're looking out into the vast cosmos, a place filled with stars, galaxies, and mysteries we thought we were beginning to understand. But then, something entirely unexpected pops into the picture, a kind of signal, a strange, almost ghostly ring, glowing faintly in the radio spectrum. It's not a star, it's not a planet, it's not even a black hole. These are odd radio circles, or ORCs, and they are rewriting what we thought we knew about the universe. What could they be? Alien megastructures? Giant remnants of cosmic explosions? Or something so strange we haven't even imagined it yet? Astronomers first stumbled across these bizarre, ring-like radio structures in 2019, thanks to a powerful survey of the sky known as the Australian Square Kilometre Array Pathfinder, a SCAP. At first, they thought these circular objects were glitches in the data, a problem with the telescope or the software. But as the team examined the findings more closely, the patterns persisted, showing up in different locations and under different conditions. These rings weren't errors. They were real, and no one knew what they were. When astronomers encounter something this perplexing, they turn to patterns and comparisons. They try to match the anomaly to something already known, maybe a supernova remnant, a galaxy halo, or a gravitational lens effect. But ORCs didn't fit into any of these categories. Their appearance is stunningly unique, faint, circular shapes with no obvious source in the visible spectrum. They're not glowing like stars or emitting energy like quasars. They exist only in the radio spectrum, silent and ghostly. The more scientists looked, the weirder these objects became. So far, fewer than 10 ORCs have been identified, and they're all millions of light years away. Most are found near large galaxies, but none of these galaxies seem to have anything immediately unusual about them. And here's the kicker: these rings are enormous. We're talking about structures that are millions of light years across, dwarfing our own Milky Way galaxy. Whatever created these massive rings must have been unimaginably powerful, or it must have taken an extraordinary amount of time to form. To make things even stranger, ORCs don't appear to emit light in any other part of the spectrum. This means you can't see them in visible light, X-rays, or even infrared. It's only through sensitive radio telescopes that they're visible, sitting quietly in the cosmic void. The absence of multi-wavelength signals makes these circles harder to study and harder to explain. It's almost like they're hiding from us, revealing just enough to keep us guessing. Speculation about ORCs has run wild in the scientific community. One theory suggests they might be the remnants of ancient, massive explosions, perhaps the kind triggered when galaxies collide or supermassive black holes violently interact. Another idea points to colossal shockwaves traveling through intergalactic gas, sparked by some unknown cosmic event billions of years ago. Some researchers have even floated the idea that ORCs could be connected to phenomena we haven't yet discovered, like exotic particles or unknown forms of energy. But let's not forget the possibility that ORCs might be linked to something fundamentally new, a category of cosmic structures we haven't even theorized yet. After all, every major discovery in astronomy, from pulsars to dark energy, started with something that didn't make sense. Could ORCs represent the next breakthrough in our understanding of the universe? What's fascinating about these circles is how they highlight the gaps in our knowledge. We like to think of the universe as something we can map and categorize, but ORCs are a stark reminder that the cosmos is still full of surprises. They raise questions that touch on the very limits of science. What mechanisms can create such massive, isolated structures? Why do they appear so faint and diffuse? And why are they only visible in radio waves? The discovery of ORCs has also sparked interest in the technology used to find them. Radio astronomy has long been a window into the invisible universe, revealing things we can't see with our eyes or optical telescopes. Tools like a SCAP and the upcoming Square Kilometre Array, SKA, are designed to push the boundaries of what we can detect, capturing data at an unprecedented scale. These technologies don't just help us find ORCs. They could uncover entirely new phenomena we haven't even dreamed of. But even with these advancements, the mystery of ORCs remains unsolved. In the years since their discovery, astronomers have proposed many explanations, but none have stuck. For every theory, there's a piece of the puzzle that doesn't quite fit. This uncertainty has turned ORCs into one of the hottest topics in astrophysics, drawing in researchers from around the world. Think about the sheer vastness of what we don't know. These strange, faint rings are likely just the tip of the iceberg. If something this massive can hide in plain sight, what else might be out there? Could ORCs be clues to even greater mysteries, like the nature of dark matter or the structure of the cosmic web? Or are they isolated phenomena, unrelated to the larger forces shaping the universe? The beauty of a mystery like this is how it forces us to confront our own limitations. ORCs challenge our assumptions, pushing us to look deeper and think harder. They remind us that the universe is not a solved puzzle but an ongoing story, filled with twists and turns we can't yet predict. As you sit with this mystery, let it sink in. Odd radio circles are not just another discovery. They are a riddle from the cosmos, a challenge from the unknown. They ask us to imagine, to question, and to explore. And who knows? Maybe the answer to this puzzle will change everything we know about the universe. The curiosity surrounding odd radio circles, ORCs, only deepens when you consider their potential significance in the grander tapestry of cosmic evolution. These enormous, enigmatic structures seem to sit at the crossroads of several scientific disciplines, drawing on everything from high-energy astrophysics to cosmology. Yet, despite all our advancements, the exact nature of these radio rings remains elusive. To appreciate the full scope of this mystery, we must dive even deeper into what makes ORCs so utterly perplexing and so important. Let's begin with their sheer size. ORCs aren't just big, they're incomprehensibly massive, spanning up to 1 million light-years across. To put that into perspective, light, the fastest thing in the universe, would take 1 million years just to travel from one edge of an ORC to the other. This scale dwarfs anything we encounter in our day-to-day understanding of space. Even the largest known galaxies pale in comparison to the immensity of these rings. The forces required to produce something so colossal defy easy explanation, hinting at processes that operate on scales far beyond our comprehension. One of the leading theories about ORCs is that they might be the remnants of gigantic shockwaves. Imagine two galaxies colliding, their stars, gas, and dark matter smashing together over billions of years. Such a collision could generate enormous ripples in the surrounding space, much like throwing a massive stone into a cosmic pond. These ripples might manifest as ORCs, visible only in radio wavelengths due to their interaction with intergalactic gas. But there's a problem with this idea. Galaxy collisions are common in the universe, yet ORCs seem to be extremely rare. If they were just a byproduct of these collisions, we'd expect to see far more of them. Another intriguing hypothesis suggests that ORCs could be linked to supermassive black holes, the mysterious giants lurking at the centers of most galaxies. When black holes consume matter, they release immense amounts of energy, sometimes ejecting jets of particles traveling at nearly the speed of light. These jets could interact with the surrounding space in ways we don't yet fully understand, potentially creating the circular patterns we see in ORCs. However, detailed studies of the galaxies near ORCs have yet to reveal the kind of black hole activity that would support this explanation. It's as if the ORCs exist in a strange, in-between state, close to galaxies, but not directly tied to them. What about the possibility that ORCs are related to phenomena entirely outside our current scientific framework? This is where things get speculative, but also exciting. Some researchers have wondered whether ORCs could be linked to exotic forms of energy, or matter. For instance, they might represent the effects of dark energy, the mysterious force driving the accelerated expansion of the universe. Alternatively, they could be evidence of interactions between particles we've never observed, hinting at new physics that could reshape our understanding of reality itself. The lack of multi-wavelength emissions from ORCs is another puzzling feature. Normally, when astronomers study celestial objects, they try to observe them across as many wavelengths as possible: radio, infrared, visible light, X-rays, and so on. Each wavelength reveals different information about the object's composition, temperature, and activity. But ORCs are stubbornly silent in all wavelengths except radio. This raises an unsettling question. Are ORCs truly rare, or are they just the tip of an unseen iceberg? If these structures are common but only detectable in radio wavelengths, it's possible we're missing an entire class of cosmic phenomena simply because we haven't been looking in the right way. To address these questions, astronomers are turning to cutting-edge technology. The Square Kilometre Array, SKA, currently under construction, promises to revolutionize radio astronomy. With its unprecedented sensitivity and resolution, the SKA could uncover thousands of new ORCs, allowing scientists to study their distribution, structure, and evolution in far greater detail. Such data could help determine whether ORCs are linked to specific types of galaxies, environments, or cosmic events. It might even reveal entirely new features of these objects, shedding light on their origins. But even as we wait for future discoveries, ORCs remind us of the importance of curiosity and open-mindedness in science. They highlight the fact that the universe is far stranger and more complex than we often assume. Each ORC is like a breadcrumb, leading us toward deeper truths about the cosmos. And while we may not have all the answers yet, the very act of searching, of asking questions and following the evidence, brings us closer to understanding our place in the grand scheme of things. Odd radio circles are more than just an astronomical curiosity. They are a challenge to our imagination, a call to expand our horizons and confront the unknown. They remind us that, for all our scientific achievements, we are still explorers, charting the edges of a vast and mysterious universe. And perhaps that's the most exciting thing of all, the realization that there are still so many mysteries left to uncover, so many questions left to ask. ORCs are a glimpse into the boundless potential of discovery, a reminder that the universe always has more surprises in store. The more we delve into the mystery of odd radio circles, ORCs, the more questions arise. What makes these objects particularly captivating is that they don't fit into the neat categories astronomers have developed over centuries of observing the cosmos. Every known phenomenon, from supernova remnants to active galactic nuclei, has a signature, a set of characteristics that help scientists identify and classify it. ORCs, however, remain an enigma, defying conventional explanation. Take, for example, their symmetry. These rings are strikingly circular, almost perfect in their shape. In the chaotic universe, such precision is rare. Natural processes tend to produce irregularities, asymmetries, and distortions. Yet ORCs appear uniformly round, as if shaped by a force or process that operates with incredible precision. This symmetry might hint at something fundamental, a process governed by the laws of physics on a scale we're only beginning to grasp. One hypothesis gaining traction is that ORCs could be relics of massive, ancient explosions, events so powerful they ripple across intergalactic space for billions of years. These explosions might be caused by phenomena like gamma-ray bursts, or the collapse of supermassive stars in the early universe. However, even the largest known explosions struggle to explain the size and faintness of ORCs. If these rings are remnants of ancient events, why do they seem so faint despite their colossal size? And why are they only detectable in radio waves? Another possibility is that ORCs might represent a form of cosmic evolution we've never encountered before. Galaxies evolve over billions of years, interacting with each other and their environments in complex ways. During this evolution, they generate a variety of structures, from spiral arms to massive jets of particles. ORCs might be an intermediate stage in this process, a phase that occurs under very specific conditions. But if that's the case, what conditions could produce such massive, faint, and symmetrical rings? Then there's the theory that ORCs are the visible signatures of shockwaves traveling through the cosmic web, the vast network of filaments and voids that connects galaxies across the universe. This web is made up of dark matter, gas, and galaxies, and it's shaped by the gravitational pull of massive structures over billions of years. If ORCs are shockwaves within this web, they could offer an unprecedented glimpse into the large-scale structure of the universe. Such a discovery would not only solve the mystery of ORCs but also provide valuable insights into how galaxies form and interact on the largest scales. Still, there's an even more speculative idea floating around: that ORCs might be connected to the mysterious phenomenon of fast radio bursts, FRBs. FRBs are intense, short-lived flashes of radio waves that originate from distant galaxies. While FRBs and ORCs appear to be fundamentally different phenomena, some researchers wonder if they might share a common origin. Could the processes that generate FRBs also create ORCs, but on vastly different timescales? It's a tantalizing possibility, but one that's difficult to prove given the limited data available. What makes the study of ORCs so challenging is their rarity. To date, fewer than 10 ORCs have been identified, and their distribution across the sky seems almost random. This scarcity makes it difficult to draw firm conclusions about their nature or origins. Are ORCs rare because they require highly unusual conditions to form, or are they simply hard to detect? If it's the latter, we may be on the verge of discovering hundreds or even thousands of ORCs as new radio telescopes come online. The role of technology in solving the ORC mystery cannot be overstated. Instruments like the Australian Square Kilometre Array Pathfinder, SCAP, and the upcoming Square Kilometre Array, SK, represent a revolution in radio astronomy. These telescopes are capable of scanning vast portions of the sky with incredible sensitivity, detecting even the faintest radio signals. As these tools become operational, they could uncover new ORCs and provide crucial data on their properties. For example, by studying the polarization of radio waves emitted by ORCs, astronomers could learn more about the magnetic fields and environments in which these objects exist. But even with these advancements, some aspects of ORCs might remain hidden. The universe is vast, and much of it is obscured by dust, gas, or the limitations of our instruments. It's entirely possible that ORCs are just the tip of an iceberg, one manifestation of a larger phenomenon we've only begun to glimpse. If that's the case, the discovery of ORCs could be the first step toward a much broader understanding of the universe and its hidden complexities. There's also the intriguing possibility that ORCs might be a clue to new physics. Every so often, astronomers encounter phenomena that challenge the existing framework of scientific knowledge. Pulsars, quasars, and even the expansion of the universe were once inexplicable mysteries. ORCs might fall into this category, representing a discovery that forces us to rethink fundamental assumptions about the cosmos. For instance, if ORCs are linked to unknown particles or forces, they could open the door to entirely new fields of study. In many ways, the mystery of ORCs embodies the essence of astronomy, the quest to understand the unknown. These faint, ghostly rings are a reminder that the universe is far more complex and surprising than we often imagine. They challenge us to look beyond what we know, to ask questions that don't have easy answers, and to push the boundaries of science in pursuit of the truth. As we continue to study ORCs, one thing is certain: they are not just an anomaly. They are a window into the unknown, a puzzle that beckons us to explore the deepest reaches of the cosmos. And in doing so, they remind us of the limitless potential of human curiosity and the enduring mystery of the universe. Odd radio circles, ORCs, are more than just a new discovery. They're a testament to how little we still understand about the universe. Despite our best efforts, ORCs continue to defy explanation, remaining an unresolved question in the field of astronomy. Yet, it is precisely this mystery that makes them so captivating. They encourage us to think beyond established theories and consider alternative explanations, no matter how unconventional they may seem. Consider the possibility that ORCs are linked to the early universe. Some researchers speculate that these structures could be remnants of events that occurred shortly after the Big Bang. During this formative period, the universe was a chaotic place, filled with intense radiation, rapidly forming galaxies, and interactions between particles we can barely comprehend. Could ORCs be echoes of primordial processes that have long since ceased to operate? If so, studying them could provide insights into the conditions of the early cosmos, revealing details about how matter first organized into the structures we see today. Another theory posits that ORCs might be connected to dark matter, the elusive substance that makes up roughly 27% of the universe's mass energy content. Unlike ordinary matter, dark matter does not emit or absorb light, making it incredibly difficult to study. However, It exerts a gravitational influence on visible matter, and is thought to play a key role in the formation of galaxies and other cosmic structures. If ORCs are somehow tied to dark matter, they could serve as indirect evidence of its properties. For instance, the circular symmetry of ORCs might reflect the behavior of dark matter halos surrounding galaxies or clusters. The notion that ORCs might be evidence of exotic physics is even more tantalizing. Could they be manifestations of phenomena predicted by advanced theoretical models, such as string theory or extra dimensions? While such ideas may sound like science fiction, history has shown that groundbreaking discoveries often come from unexpected places. ORCs might represent a similar breakthrough, pointing to aspects of the universe that lie outside our current understanding. The role of cosmic magnetism in shaping ORCs is another avenue worth exploring. Magnetic fields are a fundamental yet poorly understood component of the universe. They influence the motion of charged particles, affect the formation of stars and galaxies, and even play a role in the large-scale structure of the cosmos. If ORCs are shaped by magnetic forces, they could offer a unique opportunity to study these fields on an unprecedented scale. By analyzing the polarization of radio waves emitted by ORCs, astronomers could gain valuable information about the strength and orientation of magnetic fields in the regions where these structures exist. Another intriguing aspect of ORCs is their potential to illuminate the interactions between galaxies and their environments. Galaxies are not isolated entities. They exist within larger structures, such as galaxy clusters and the cosmic web. These environments influence their evolution, driving processes like star formation, gas accretion, and mergers. ORCs might be byproducts of these interactions, serving as markers of events that occur on intergalactic scales. For instance, they could be the result of shockwaves generated by the movement of galaxies through dense regions of the cosmic web. The discovery of ORCs also raises questions about the limitations of our observational techniques. Until recently, these structures went unnoticed, despite their enormous size. This suggests that there may be other phenomena lurking in the data, waiting to be uncovered. As radio astronomy continues to advance, we may find not only more ORCs but also entirely new classes of objects. Each discovery will add another piece to the puzzle, helping us build a more complete picture of the universe. At the heart of the ORC mystery is a profound question: what forces are capable of creating such vast, symmetrical structures? To answer this, scientists are drawing on a range of disciplines, from astrophysics to cosmology. They are also relying on collaboration, with teams of researchers around the world pooling their expertise to tackle the problem. This interdisciplinary approach is crucial, as ORCs do not fit neatly into any one category of astronomical phenomena. Solving their mystery will likely require new ideas, new tools, and a willingness to challenge established paradigms. As we ponder these questions, it's worth considering what ORCs reveal about the nature of science itself. Astronomy is often viewed as a field that deals with certainties, laws of physics, well-documented phenomena, and precise measurements. But ORCs remind us that science is, at its core, a process of discovery. It thrives on the unknown, on the gaps in our knowledge that drive us to ask questions and seek answers. Each ORC is a challenge, a reminder that the universe is far more complex and mysterious than we often imagine. What's particularly exciting about ORCs is their potential to inspire future generations of scientists. Just as the discovery of pulsars or the cosmic microwave background sparked new lines of research, ORCs could do the same. They represent a frontier in astronomy, one that invites exploration and innovation. Who knows what discoveries will follow in their wake? Perhaps ORCs will lead to the identification of other unusual structures, or perhaps they will serve as a stepping stone to even greater mysteries. ORCs are more than just astronomical objects. They are symbols of human curiosity and the drive to understand the unknown. They remind us that, for all our achievements, we have barely scratched the surface of what the universe has to offer. And while we may not yet know what ORCs are or where they come from, the journey to uncover their secrets promises to be one of the most exciting chapters in the history of science. The search for answers surrounding odd radio circles, ORCs, represents a thrilling crossroads in our understanding of the universe. These enigmatic structures not only challenge existing theories but also open new avenues of exploration. Their mystery touches on some of the most profound questions in astronomy, physics, and cosmology. How do galaxies evolve? What is the role of unseen forces in shaping the cosmos? Could we be missing entire categories of phenomena simply because we lack the tools or perspective to detect them? One of the more captivating theories regarding ORCs is that they may result from processes tied to supermassive black holes at the centers of galaxies. Supermassive black holes, often millions or even billions of times the mass of our Sun, are among the most energetic objects in the universe. They power quasars and active galactic nuclei (AGN), emitting jets of charged particles that stretch across thousands of light-years. Some astronomers have suggested that ORCs could be massive shock waves or bubble-like structures formed when these jets interact with the surrounding intergalactic medium. If true, studying ORCs could yield insights into how black holes influence their environments and how energy is distributed across vast cosmic scales. On the other hand, the alignment and distribution of ORCs raise the possibility of large-scale cosmic events. One hypothesis posits that they could be the remnants of galaxy mergers, cataclysmic events where two or more galaxies collide and combine. Such mergers can trigger massive bursts of star formation and the expulsion of material into the intergalactic medium. ORCs, in this scenario, might represent the outermost echoes of these interactions, visible only in the radio spectrum. The puzzle becomes even more intriguing when considering the uniformity and symmetry of ORCs. Nature often creates chaotic and irregular structures, especially on such enormous scales. The nearly perfect circular shape of ORCs stands out, suggesting an underlying mechanism that favors such symmetry. This might involve magnetic fields, plasma dynamics, or even unknown physical laws. Some researchers have speculated that the symmetry could point to phenomena governed by fundamental constants of nature, those unchanging numbers that define the behavior of the universe. Adding to the intrigue is the possibility that ORCs could act as a kind of cosmic time capsule. Radio waves take billions of years to traverse the vast distances of space, meaning that when we observe ORCs, we are looking into the distant past. The light, or radio emissions, we see today originated long before the Earth even formed. By studying ORCs, we are effectively peering into a time when the universe was much younger. This could offer a glimpse into processes that have long since ceased to operate, providing a rare opportunity to study the history of the cosmos. However, ORCs also raise questions about the limitations of our current observational methods. They were only recently discovered, despite their massive size, which suggests that our understanding of the radio spectrum is incomplete. As new telescopes like the Square Kilometre Array, SKA, come online, we may detect more ORCs, or phenomena even stranger. These discoveries will require astronomers to revisit existing data with fresh eyes, armed with new tools and techniques. The technological implications of ORCs are just as fascinating as their scientific ones. Radio astronomy relies on arrays of antennas spread across vast distances to capture faint signals from the cosmos. The discovery of ORCs underscores the importance of refining these technologies. Improved sensitivity and resolution will not only help identify more ORCs but will also deepen our understanding of their structure and composition. Could they be made of plasma, dust, or something entirely unknown? Each clue brings us closer to solving the mystery. Speculation about ORCs inevitably leads to broader questions about the universe's unseen components. For example, could these structures be related to the mysterious, dark energy that drives the accelerated expansion of the universe? Dark energy remains one of the greatest enigmas in modern cosmology, accounting for roughly 68% of the universe's total energy density. If ORCs are connected to this elusive force, they could provide a new way to study its effects. Another consideration is whether ORCs are truly a new class of object, or if they fit into an existing category. The cosmic web, a vast network of filaments and voids that defines the large-scale structure of the universe, might offer some context. Perhaps ORCs are regions where the web's filaments intersect, creating zones of intense activity. Alternatively, they might represent voids, regions of space where matter is unusually sparse, allowing for unique interactions. The role of artificial intelligence, AI, and machine learning in studying ORCs cannot be overstated. These technologies are increasingly being used to analyze vast amounts of astronomical data, identifying patterns and anomalies that would be impossible for humans to detect. AI has already played a role in confirming the existence of ORCs by sifting through the immense datasets generated by radio telescopes. As these tools become more sophisticated, they will undoubtedly reveal even more about the nature of these objects. As the study of ORCs progresses, one thing becomes clear: they are a reminder of how much we still have to learn. Despite centuries of scientific progress, the universe continues to surprise us, presenting puzzles that defy easy explanation. Each new discovery forces us to confront the limits of our knowledge and inspires us to push those boundaries further. In this sense, ORCs are more than just astronomical phenomena. They are symbols of humanity's enduring curiosity and determination to understand the cosmos. While we may not yet have definitive answers about ORCs, the journey to uncover their secrets is already reshaping our understanding of the universe. Whether they are linked to black holes, dark matter, or something entirely unexpected, ORCs promise to reveal new truths about the nature of reality. And as we gaze into the night sky, pondering these mysterious rings, we are reminded of the vastness of the universe, and the endless possibilities it holds. The mystery of odd radio circles, ORCs, doesn't just lie in their structure and origin. It also invites us to rethink our understanding of the universe's hidden complexities. One of the most compelling aspects of ORCs is their potential to reveal processes that operate on scales we can barely comprehend. Each ORC spans hundreds of thousands of light-years, making them some of the largest structures ever detected. Yet their faint radio emissions suggest they might be delicate remnants of cosmic events that occurred billions of years ago. What sort of events could create such massive yet ephemeral imprints in the cosmos? One hypothesis that has captured the imagination of researchers is the idea that ORCs might be linked to ancient galactic explosions, specifically those involving the sudden collapse of massive stars or supernovae that occurred in the universe's distant past. These cosmic cataclysms release immense amounts of energy, often creating shockwaves that ripple through surrounding interstellar material. If ORCs are the remnants of such events, their study could help us understand how stars and galaxies evolved in the early universe. However, this explanation raises more questions than it answers. If supernovae or similar events created ORCs, why do these structures appear so rarely in the data? After all, supernovae are relatively common in cosmic terms, occurring regularly across the observable universe. The rarity of ORCs suggests that if they are linked to supernovae, the conditions required to form them must be extraordinarily specific, perhaps involving a combination of factors like the size of the star, the density of surrounding material, and the presence of strong magnetic fields. Identifying these conditions could become a key focus of future research. ORCs also challenge our assumptions about the scale of cosmic phenomena. Traditional models of galaxy formation and evolution emphasize localized processes, such as star formation, gravitational interactions, and the influence of black holes. ORCs, however, suggest that there may be large-scale dynamics at play, processes that operate across the vast expanses of intergalactic space. These could include interactions between galaxy clusters, the influence of dark matter, or even the effects of cosmic inflation, the rapid expansion of the universe in its earliest moments. The role of dark matter in the formation of ORCs is particularly intriguing. Dark matter, an invisible substance that makes up about 27% of the universe's mass energy content, is thought to play a crucial role in shaping the large-scale structure of the cosmos. Some researchers have speculated that ORCs might be regions where dark matter is especially concentrated, creating gravitational wells that influence the behavior of surrounding gas and plasma. Alternatively, ORCs could represent the effects of dark matter annihilation, a theoretical process in which particles of dark matter collide and convert into energy. If ORCs are connected to dark matter, they could provide a rare opportunity to study this elusive substance directly. Another possibility is that ORCs are not remnants of past events but rather active phenomena still unfolding in the present. For instance, they might be massive cosmic engines, continuously powered by processes like magnetic reconnection or plasma instabilities. Magnetic reconnection occurs when magnetic field lines in a plasma snap and reconnect, releasing vast amounts of energy. This process is already known to occur in the Sun's corona and in Earth's magnetosphere, but on much smaller scales. If ORCs represent magnetic reconnection on a galactic or intergalactic scale, they could provide insights into the behavior of magnetic fields in extreme environments. The symmetry and alignment of ORCs also raise intriguing possibilities about their connection to the cosmic web, the vast, interconnected network of filaments, clusters, and voids that make up the universe's large-scale structure. Some scientists have proposed that ORCs could be related to the intersections of filaments within the cosmic web, where matter and energy are concentrated. These intersections might create conditions favorable for the formation of massive shockwaves or bubbles, which could manifest as ORCs in the radio spectrum. Moreover, the discovery of ORCs has implications for our search for extraterrestrial intelligence, SETI. While there is no direct evidence to suggest that ORCs are artificial in origin, their unusual properties have led some to wonder whether they could be the signatures of advanced civilizations. For example, ORCs might represent the byproducts of massive engineering projects, such as Dyson spheres or other megastructures designed to harness energy on a galactic scale. Alternatively, they could be the result of exotic communication methods that operate in the radio spectrum. While these ideas remain speculative, they highlight the importance of keeping an open mind when exploring the unknown. One of the most exciting aspects of ORC research is the potential for serendipitous discoveries. Astronomy has a long history of uncovering unexpected phenomena. Pulsars, quasars, and even cosmic microwave background radiation were all initially discovered by accident. The study of ORCs could similarly lead to breakthroughs in entirely unrelated areas of science. For instance, analyzing the properties of ORCs might improve our understanding of the interstellar medium, the mysterious stuff that fills the spaces between stars and galaxies. It could also lead to advancements in radio astronomy techniques, paving the way for new discoveries. The ongoing investigation of ORCs also underscores the importance of international collaboration in science. Projects like the ESCAP survey, which first identified ORCs, involve teams of researchers from around the world, pooling their expertise and resources to tackle complex problems. As the search for ORCs expands to other telescopes and observatories, this spirit of collaboration will be essential for unraveling their mysteries. In the coming years, new observational tools will play a crucial role in advancing our understanding of ORCs. The Square Kilometre Array, SKA, currently under construction, promises to revolutionize radio astronomy with its unprecedented sensitivity and resolution. Once operational, the SKA will be able to detect even fainter ORCs, as well as other phenomena that have so far eluded detection. Similarly, upcoming space-based observatories like the James Webb Space Telescope, JWST, and the European Space Agency's Athena mission could complement radio observations by studying ORCs in other wavelengths, such as infrared or X-rays. The discovery of odd radio circles represents a thrilling moment in the history of astronomy, a reminder that the universe still holds countless secrets waiting to be uncovered. These mysterious structures challenge our understanding of cosmic processes, push the boundaries of existing theories, and inspire new lines of inquiry. Whether they are remnants of ancient explosions, active cosmic engines, or something entirely unexpected, ORCs are a testament to the endless possibilities of scientific exploration. As we continue to study these enigmatic circles, we are reminded of the vastness and complexity of the universe, a realm far stranger and more fascinating than we could ever imagine. The journey to uncover the truth about ORCs is only just beginning, and it promises to reshape our understanding of the cosmos in ways we cannot yet predict. The deeper we dive into the mystery of odd radio circles, ORCs, the more we realize how much we don't know about the universe. These enigmatic structures are challenging astronomers to rethink established ideas and develop new tools to interpret their findings. ORCs represent the perfect intersection of curiosity and science, reminding us that every discovery, no matter how strange, is an invitation to learn more. One of the key questions scientists are grappling with is why ORCs appear as perfectly circular structures. Circles in astronomy often indicate symmetry, which usually suggests an underlying process that distributes energy or matter evenly. For example, supernova remnants in planetary nebulae are often spherical because the explosions that create them radiate energy equally in all directions. But ORCs differ from these well-understood phenomena in significant ways, especially because their circular outlines are visible only in the radio spectrum and not in optical or X-ray wavelengths. This selective visibility suggests that the mechanisms producing ORCs may be entirely unique, or perhaps even involve physics we haven't encountered before. The circular symmetry of ORCs might be linked to shockwaves propagating through the interstellar medium. Shockwaves are common in astrophysical environments, occurring whenever a sudden burst of energy pushes against surrounding material. Imagine a ripple expanding outward in a pond after a stone is dropped into it. On a cosmic scale, the energy source could be anything from a supermassive black hole ejecting jets to a massive merger of galaxy clusters. But why would these shockwaves produce such clean, well-defined rings? The answer likely lies in the interplay between energy, magnetic fields, and the density of the surrounding medium. Magnetic fields, in particular, may play a critical role in shaping ORCs. Magnetic fields are ubiquitous in space, influencing the behavior of charged particles and shaping the structure of galaxies. If an ORC is the result of a shockwave passing through a region of space with a strong, uniform magnetic field, the interaction could produce a circular outline detectable in radio wavelengths. This hypothesis could be tested by studying the polarization of the radio waves emitted by ORCs, which would reveal information about the magnetic fields involved. The idea that ORCs might be linked to supermassive black holes has also gained traction among researchers. Black holes are known for their intense gravitational pull, but they can also generate enormous amounts of energy through the process of accretion, when matter spirals inward and heats up as it approaches the event horizon. Some black holes eject jets of plasma at nearly the speed of light, creating structures that can extend for thousands of light years. If an ORC were associated with such a jet, its circular appearance might represent the shockwave created as the jet interacts with surrounding material. This would explain why ORCs are often found near galaxies with active central black holes. However, the black hole hypothesis doesn't fully account for the size and rarity of ORCs. The fact that these structures are so enormous and yet so faint suggests that whatever is producing them operates on scales far beyond what we usually associate with black hole activity. This has led some researchers to explore more exotic explanations, including the possibility that ORCs are connected to cosmic inflation or the early universe. Cosmic inflation refers to a period of rapid expansion that occurred fractions of a second after the Big Bang. During this time, tiny quantum fluctuations were stretched to macroscopic scales, seeding the formation of galaxies and other large-scale structures. It's possible that ORCs are imprints of these ancient fluctuations, preserved in the cosmic microwave background and now detectable in the radio spectrum. If this is the case, studying ORCs could provide a direct window into the conditions of the universe's infancy, a prospect that would revolutionize our understanding of cosmology. Another speculative idea is that ORCs might be the result of interactions between different dimensions. Some theories in theoretical physics, such as string theory, propose that the universe has more dimensions than the three spatial dimensions we perceive. If these extra dimensions influence the behavior of matter and energy, they might create phenomena that appear unusual or inexplicable from our limited perspective. ORCs could represent one such phenomenon, offering indirect evidence for the existence of higher dimensions. Even as astronomers debate these possibilities, new observations are adding to the mystery. The discovery of additional ORCs since their initial identification suggests that these structures are more common than previously thought, but their faintness makes them difficult to detect. Advanced radio telescopes, such as the upcoming Square Kilometre Array, SKA, will likely uncover many more ORCs in the coming years, providing a larger sample for study. These observations could reveal patterns in the distribution, size, or orientation of ORCs, offering clues about their origin. The role of artificial intelligence, AI, in the study of ORCs is also worth noting. Modern astronomical surveys generate vast amounts of data, far more than any team of researchers could analyze manually. AI algorithms can sift through this data, identifying potential ORCs and distinguishing them from other radio sources. Machine learning techniques could even help classify ORCs based on their properties, leading to new insights about their nature. Despite the progress being made, the study of ORCs is still in its infancy. Much of what we know about them comes from a handful of observations, and every new discovery has the potential to upend existing theories. This uncertainty is both a challenge and an opportunity, inviting scientists to think creatively and collaborate across disciplines. Physicists, astronomers, and data scientists all have a role to play in unraveling the mystery of ORCs, as do engineers and technologists developing the next generation of telescopes. Ultimately, the true significance of odd radio circles may not lie in what they are, but in what they represent, a reminder of the universe's boundless capacity for surprise. Just as the discovery of pulsars and quasars transformed our understanding of the cosmos, ORCs have the potential to reveal new layers of complexity and beauty. They challenge us to look beyond the familiar and to embrace the unknown, a sentiment that lies at the heart of all scientific exploration. As we continue to study ORCs, we are reminded that every unanswered question is an opportunity to learn, to grow, and to marvel at the vastness of the universe. The story of ORCs is far from over, and the discoveries yet to come may be even more astonishing than we can imagine. The pursuit of understanding odd radio circles, ORCs, forces us to confront a fundamental truth about space exploration. Each new mystery not only expands the boundaries of what we know but also reveals how much we have yet to discover. This duality, the exhilaration of discovery tempered by the humility of our ignorance, is what makes the ORC phenomenon so captivating. These faint, ethereal rings are challenging our most established paradigms, compelling scientists to reconsider what they thought they understood about the cosmos. One of the most fascinating aspects of ORCs is their sheer scale. To truly grasp their enormity, consider that these structures span millions of light years, dwarfing even the largest galaxies. Their vastness suggests that whatever is producing them must be an event or process operating on an unimaginably massive scale. This realization has led researchers to investigate scenarios involving cosmic-scale interactions, such as galaxy mergers or collisions between massive structures like galaxy clusters. Galaxy mergers, in particular, are a compelling possibility. When two galaxies collide, their stars mostly pass by each other due to the vast distances between them, but the gas, dust, and dark matter they contain interact in complex and dramatic ways. These interactions can trigger bursts of star formation, fuel the activity of central supermassive black holes, and create massive shockwaves that ripple through the surrounding intergalactic medium. If ORCs are linked to such shockwaves, they might represent a previously unrecognized consequence of these cosmic collisions, offering a new perspective on the life cycles of galaxies. Another possibility is that ORCs are related to phenomena occurring in the spaces between galaxies, in the so-called cosmic web. The cosmic web is the large-scale structure of the universe, consisting of vast filaments of dark matter, gas, and galaxies, interspersed with enormous voids. It is within this web that much of the universe's mass resides, yet it remains poorly understood because it is largely invisible to conventional telescopes. If ORCs are connected to processes occurring within the cosmic web, their study could provide valuable insights into this hidden structure, revealing the dynamics that govern the universe on its largest scales. One of the more speculative, but nonetheless intriguing, ideas is that ORCs might be the signatures of exotic astrophysical objects or phenomena. For example, some researchers have proposed that ORCs could be the remnants of cosmic strings, hypothetical one-dimensional defects in the fabric of space-time that might have formed during the early universe. If two cosmic strings were to intersect and annihilate, they could release enormous amounts of energy, potentially creating structures like ORCs. Although this idea is highly theoretical, it highlights the diverse range of possibilities scientists are considering as they attempt to explain these mysterious rings. Adding another layer of intrigue is the fact that ORCs are detectable only in radio wavelengths. This specificity suggests that they are associated with processes that generate synchrotron radiation, a type of electromagnetic emission produced when charged particles spiral around magnetic field lines at near light speeds. Synchrotron radiation is a hallmark of many high-energy astrophysical phenomena, from supernova remnants to jets from active galactic nuclei. However, the synchrotron emission from ORCs appears to lack a clear source, making it difficult to pinpoint what is driving the phenomenon. The absence of optical or X-ray counterparts to ORCs complicates matters further. Most astrophysical objects and events emit radiation across multiple wavelengths, providing a broader picture of their properties and behavior. The fact that ORCs are invisible in other parts of the spectrum might indicate that they are composed of extremely low-density material, or that the processes creating them are uniquely tuned to emit radio waves. Alternatively, it could mean that ORCs are located at such great distances that their emission in other wavelengths is too faint to detect, placing them among the most distant structures ever observed. In the quest to unravel the mystery of ORCs, technology plays a crucial role. Current radio telescopes like the Australian Square Kilometre Array Pathfinder, (SCAP), and the Meerkat Array in South Africa are providing unprecedented sensitivity and resolution, enabling astronomers to detect faint signals that would have been missed by earlier instruments. These facilities are also helping to refine our understanding of ORCs by allowing scientists to study their properties in greater detail. For example, observations with the SCAP have revealed that some ORCs are not entirely circular but exhibit subtle asymmetries, suggesting that their shapes may be influenced by local environmental factors. Looking ahead, the next generation of telescopes promises to revolutionize our ability to study ORCs and other mysterious phenomena. The Square Kilometre Array, (SKA), currently under construction, will be the largest and most powerful radio telescope ever built, capable of detecting radio signals from the earliest epochs of the universe. With its unparalleled sensitivity and wide field of view, the SKA is expected to uncover thousands of new ORCs, providing a much larger sample for analysis and helping to answer fundamental questions about their nature and origin. As the data pours in, the theoretical models will become increasingly sophisticated, incorporating insights from observations as well as advances in computational astrophysics. Simulations of large-scale cosmic structures, powered by some of the world's most advanced supercomputers, are already being used to test hypotheses about ORCs. These simulations allow scientists to recreate the conditions under which ORCs might form, exploring scenarios that range from galaxy mergers to interactions between dark matter and intergalactic gas. Despite all these efforts, the true nature of ORCs remains elusive, and this uncertainty is a powerful reminder of the limits of our knowledge. But it is also a testament to the resilience and creativity of the scientific community, which thrives on challenges like this one. The study of ORCs is not just about solving a single mystery. It is about pushing the boundaries of what we know and opening new avenues of exploration. In many ways, the mystery of ORCs embodies the spirit of astronomy itself, a field that is as much about asking questions as it is about finding answers. Each ORC represents a tiny piece of a much larger puzzle, one that spans the entire universe and connects us to its deepest mysteries. By studying these enigmatic structures, we are not only learning about the cosmos but also about ourselves, our ability to wonder, to imagine, and to seek out the unknown. The journey to understand ORCs is far from over, and it is likely that the most exciting discoveries are still to come. As new technologies emerge and our knowledge grows, we may one day look back on the discovery of ORCs as a turning point in our understanding of the universe. Until then, these mysterious rings will continue to inspire curiosity and awe, reminding us that the cosmos is far more complex and beautiful than we can ever fully comprehend. The potential implications of solving the mystery of odd radio circles, ORCs, extend beyond astronomy, touching on fields as varied as physics, cosmology, and even the philosophy of science. Each hypothesis about ORCs opens doors to other inquiries that could redefine our understanding of the universe's fundamental workings. From revealing the mechanics of intergalactic structures to offering clues about the early universe, ORCs are far more than just isolated phenomena. They are a key to unraveling interconnected mysteries. One particularly intriguing avenue of study is the connection between ORCs and dark matter. As we know, dark matter is a mysterious, invisible substance that makes up about 27% of the universe's mass energy content. Despite its abundance, it has never been directly observed. Its presence is inferred from its gravitational effects on visible matter. Some researchers speculate that ORCs might serve as indirect evidence of dark matter interactions. For example, if ORCs are located in regions where dark matter is particularly dense, they might be the result of dark matter's influence on surrounding gases or magnetic fields. This connection, if proven, could provide a rare observational foothold into the elusive nature of dark matter. Another related mystery involves dark energy, the force believed to drive the accelerating expansion of the universe. Although ORCs are not directly linked to dark energy in any current theories, their study could shed light on the large-scale structure of the universe, which is shaped in part by the interplay between dark matter and dark energy. By mapping the distribution and properties of ORCs, scientists may gain insights into how these two enigmatic forces interact on cosmic scales. As if these possibilities weren't exciting enough, ORCs also challenge some of our basic assumptions about astrophysical processes. For instance, if ORCs are the remnants of explosive events like supernovae or gamma-ray bursts, their massive sizes imply that such events can have far-reaching effects that were previously underestimated. Alternatively, if ORCs are linked to activity in the early universe, they might represent the afterglow of primordial events, such as the formation of the first galaxies or the reionization of the cosmos. These connections could fundamentally alter our understanding of cosmic evolution, showing us how seemingly isolated phenomena are part of a much larger and more intricate web of interactions. The cultural and philosophical implications of ORCs are just as profound as the scientific ones. Throughout history, humanity has looked to the stars for answers to some of life's biggest questions. Where do we come from? Are we alone? What is our place in the universe? Discoveries like ORCs remind us that the universe is not only vast but also filled with phenomena that defy easy explanation. This sense of mystery and wonder is a powerful motivator, driving us to explore further and think more deeply about our existence. Moreover, the discovery of ORCs exemplifies the collaborative nature of modern science. Observatories from around the world, including ESCAP in Australia and Meerkat in South Africa, have contributed to the study of these enigmatic structures. Scientists from diverse backgrounds and disciplines are pooling their expertise, resources, and creativity to tackle the challenge. This global effort underscores the importance of cooperation in addressing the big questions of our time. In the coming years, the study of ORCs will undoubtedly benefit from advancements in technology and methodology. As previously mentioned, the Square Kilometre Array, SKA, is expected to play a pivotal role in this endeavor. With its unprecedented sensitivity, the SKA will allow scientists to detect even fainter radio emissions, potentially uncovering thousands of new ORCs and refining our understanding of their properties. Additionally, advances in machine learning and data analysis are enabling researchers to process the vast amounts of information generated by modern telescopes, identifying patterns and correlations that might otherwise go unnoticed. Despite these advancements, the mystery of ORCs is a reminder of the limits of our knowledge and the challenges inherent in studying the cosmos. Unlike laboratory experiments, which can be controlled and replicated, astronomical observations are often one-of-a-kind events. The light from distant objects takes millions or even billions of years to reach us, meaning that we are essentially looking at snapshots of the past. This time delay adds an extra layer of complexity to the study of ORCs, as it forces scientists to piece together the story of these structures from incomplete and often indirect evidence. But perhaps this very difficulty is what makes the study of ORCs so rewarding. The process of uncovering their secrets is not just about solving a puzzle, it's about pushing the boundaries of what we thought was possible. Each new observation, hypothesis, and breakthrough brings us one step closer to a deeper understanding of the universe, while also reminding us that there will always be more to learn. As we continue to explore the mystery of ORCs, it is worth reflecting on what they represent. In a sense, they are a symbol of the unknown, a reminder that even in an era of rapid technological and scientific progress, there are still phenomena that elude explanation. They challenge us to remain curious, to question our assumptions, and to embrace the uncertainty that lies at the heart of discovery. Ultimately, the study of ORCs is not just about understanding a specific phenomenon. It is about expanding our horizons and deepening our connection to the cosmos. These mysterious rings, floating silently in the depths of space, are a testament to the complexity and beauty of the universe. And as we strive to unravel their secrets, we are reminded of our own capacity for wonder, imagination, and the relentless pursuit of knowledge. As the search for answers about odd radio circles, ORCs, progresses, it's important to remember the larger context of astrophysical research. Each new discovery, whether it involves ORCs or other phenomena, has the potential to lead to profound shifts in how we understand the universe. For example, the study of ORCs could reveal new insights into the formation and behavior of cosmic structures, challenging existing theories or even giving rise to entirely new ones. The mystery of ORCs is also a reminder of the scale of cosmic exploration. We are investigating events and structures that occurred millions or even billions of years ago, reaching across unimaginable distances. The study of ORCs is part of humanity's ongoing effort to comprehend the nature of the cosmos, yet we are only scratching the surface. Each discovery leads to more questions, fueling a cycle of inquiry and exploration that drives science forward. It is in this pursuit of knowledge that we find not only answers but new mysteries that expand our understanding of existence itself. The discovery of ORCs is a testament to the power of advanced technology and innovation in reshaping our view of the universe. Instruments like the Australian Square Kilometre Array Pathfinder, SCAP, and the Meerkat Radio Telescope in South Africa, combined with cutting-edge computational tools, are allowing scientists to explore space in ways that were once unimaginable. These technologies open up new frontiers in astronomy, enabling us to observe the universe's most elusive and enigmatic features, such as the strange and fascinating radio circles. What's more, the global collaboration involved in such projects demonstrates how science transcends. The more we study ORCs, the more we come to realize how much we don't know about the universe. These cosmic structures serve as a reminder of the limits of our current understanding. Are they the remnants of ancient stellar explosions? Do they point to the presence of new types of cosmic phenomena, perhaps related to dark matter or the early universe? With every new discovery, we are forced to rethink our models of the cosmos and adjust our hypotheses. This iterative process is fundamental to the scientific method and drives progress in our understanding of the universe. At the heart of this exploration is the question of what ORCs can teach us about the fundamental forces of nature. Could they reveal something about the interactions between electromagnetic radiation and unseen matter? Are they connected to the larger structures of the universe, like superclusters or filaments of dark matter? To answer these questions, scientists will need to continue refining their observations, improving their models, and thinking creatively about the nature of these enigmatic radio signals. In some ways, ORCs also challenge our understanding of what constitutes a mystery in space. Traditionally, when we think of cosmic phenomena, we imagine grand, violent events like supernovae, black holes, or galaxy collisions. ORCs, by contrast, seem deceptively quiet. They are not explosions or flashes of intense energy, but rather gentle, ring-like structures that exist in the distant reaches of space. And yet, their very silence makes them even more intriguing. What causes these structures to form? How do they persist in space? And why are they only now being detected? The search for answers is far from over, and it's impossible to say where it will lead. ORCs could represent a new class of astronomical objects, or they could turn out to be the result of rare and previously unknown cosmic events. They could reveal new dimensions of space and time, or they might help us refine our understanding of the universe's earliest moments. The possibilities are endless, and each new discovery brings us one step closer to uncovering the truth. One of the more exciting prospects in the study of ORCs is the potential to uncover clues about the formation of galaxies. Galaxies, as we understand them, are vast collections of stars, gas, dust, and dark matter that are held together by gravity. They are the building blocks of the universe, and their formation is a key focus of modern cosmology. ORCs could potentially help us understand how galaxies form, evolve, and interact with one another. If the radio emissions from ORCs are tied to processes that occur in the early stages of galaxy formation, they might offer insights into the conditions that gave rise to some of the universe's earliest cosmic structures. Moreover, the existence of ORCs raises interesting questions about the interaction between matter and energy in the cosmos. The fact that these structures are made up of radio waves, the form of electromagnetic radiation most commonly associated with energy, suggests that something is generating these waves on an enormous scale. Whether it's a galactic engine or an entirely new process remains unclear. But whatever the cause, it indicates that the universe is far more complex than we might have imagined. At the same time, the study of ORCs calls attention to the limitations of current observational methods. Despite the breakthroughs made by radio telescopes like ESCAP and MEERKAT, we are still only able to observe a small fraction of the universe's total radio emissions. Most of the cosmos remains invisible to us, and it's likely that there are many more cosmic mysteries yet to be discovered. As technology improves, we will gain the ability to peer deeper into space, uncovering new phenomena that will reshape our understanding of the cosmos. For now, the mystery of ORCs remains just that, a tantalizing enigma that invites us to explore further. Scientists are working hard to analyze the data they have gathered, testing new hypotheses, and refining their models. And with each new breakthrough, we move closer to unraveling the truth about these strange radio circles. It may take years, or even decades, before we fully understand what ORCs are and how they fit into the larger puzzle of the universe. But one thing is certain: the search for answers will continue to push the boundaries of scientific knowledge, leading to discoveries that will forever change our view of the cosmos. As we continue to ponder the nature of ORCs, it's essential to recognize that this mystery, like so many others in science, is not just about solving a riddle. It's about the journey, the process of discovery that takes us into the unknown and forces us to question everything we think we know. The study of ORCs is a perfect example of how, in the vastness of space, every answer we uncover leads to even more questions. It is this endless curiosity that fuels scientific progress and drives us to look deeper, think harder, and reach farther into the mysteries of the universe. The story of ORCs is still being written, and only time will tell where it leads. As the mystery of odd radio circles, ORCs, deepens, it also challenges our expectations and assumptions about space and the forces at play within it. These strange radio structures remind us that the universe is far more complex than we can fathom, with many phenomena remaining entirely out of sight or beyond the reach of our current instruments. ORCs are not just isolated curiosities. They could be part of a larger, interconnected web of cosmic events and structures, waiting to be unraveled by future research. One of the biggest questions in the study of ORCs is their origin. While some scientists speculate that ORCs might be related to the cosmic explosions of supernovae, others suggest that these structures could be the result of more exotic phenomena, such as interactions between massive black holes or the rare remnants of ancient stars. However, until more data is collected, we can only theorize about the exact cause behind these enigmatic radio circles. Another fascinating aspect of ORCs is their potential to illuminate the nature of dark matter and dark energy, two of the most mysterious and elusive components of the universe. We know that these forces exist because of their gravitational effects on visible matter, but we still don't fully understand what they are or how they work. Could the formation of ORCs be tied to the behavior of dark matter? Could they help us understand how dark energy shapes the expansion of the universe? These questions are at the forefront of current research, and any breakthroughs could significantly impact our broader understanding of the cosmos. In the quest to understand ORCs, scientists are developing more advanced models and using new tools to simulate cosmic phenomena. These simulations are critical for testing different theories and narrowing down the potential causes of ORCs. With the power of supercomputers, researchers are now able to simulate the behavior of galaxies, black holes, and other cosmic entities in a way that wasn't possible even a few decades ago. These simulations are helping scientists visualize how ORCs might form and evolve over time, providing valuable insights into the underlying physics at play. However, one of the greatest challenges in studying ORCs is the sheer scale of the universe. The distances involved are so vast that even with the most advanced telescopes, we are only able to glimpse tiny fragments of a much larger picture. The radio emissions from ORCs, for instance, are so faint and dispersed across enormous distances that it's easy to miss them if the conditions aren't just right. This is why it took so long for scientists to detect them in the first place. It's also why we can't yet be certain about their full range or behavior. There are likely many more ORCs scattered throughout space, waiting to be discovered. As we learn more about ORCs, we may also gain insights into the formation and evolution of galaxies. Galaxies are the building blocks of the universe, and understanding how they form, grow, and interact is one of the key goals of modern astrophysics. ORCs could represent a previously unknown aspect of this process. Could these radio circles be the result of early galactic collisions, or could they point to a new mechanism by which galaxies form and evolve? The answers to these questions could have profound implications for our understanding of the universe's past, present, and future. The study of ORCs also highlights the interconnected nature of the universe. While we often think of space as being filled with isolated stars, planets, and galaxies, the reality is much more complex. Galaxies are not static objects, they are constantly interacting with each other, exchanging matter, and evolving over time. This interconnectedness could be key to understanding ORCs. Perhaps these radio circles are the result of interactions between multiple galaxies, or perhaps they are a byproduct of the chaotic forces that shape the universe. Whatever the cause, it's clear that ORCs are linked to some of the most fundamental processes that govern the cosmos. The ongoing exploration of ORCs is also part of a larger, global effort to understand the universe. Astronomy is one of the most collaborative fields of science, with researchers from all over the world working together to uncover the secrets of the cosmos. International projects like the Square Kilometre Array, (SKA), and the Event Horizon Telescope, (EHT), are pushing the boundaries of what we can observe, and they are making it possible for scientists to detect and study cosmic phenomena that were once beyond our reach. These projects are helping to bring together researchers, astronomers, and engineers from diverse backgrounds, all working toward a common goal: to explore the unknown and expand our understanding of the universe. In the future, new telescopes and space-based observatories could provide us with even more detailed data about ORCs and other cosmic phenomena. Instruments like the James Webb Space Telescope, JWST, which is set to launch in the coming years, promise to revolutionize our understanding of space. Equipped with advanced infrared capabilities, the JWST will be able to peer deeper into space than ever before, revealing hidden structures and phenomena that are invisible to current instruments. It's possible that ORCs, along with other mysterious cosmic objects, could be observed in unprecedented detail, offering new insights into their origins and behavior. But for now, the mystery of ORCs remains just that, a tantalizing puzzle that beckons us to dig deeper. What causes these bizarre radio structures? Why do they exist in such vast, seemingly empty stretches of space? Could they be a key to understanding some of the universe's greatest mysteries, such as dark matter, dark energy, or the formation of galaxies? These questions are not easily answered, but the pursuit of answers is what drives science forward. Each new discovery brings us closer to a greater understanding of the cosmos, and each new mystery, like ORCs, provides an opportunity for us to expand our horizons and challenge our assumptions about the universe. As we continue to investigate these fascinating radio circles, we are reminded of the boundless curiosity that fuels scientific discovery. Every new discovery, whether it's the detection of an ORC, the observation of a distant galaxy, or the detection of gravitational waves, adds to our ever-growing knowledge of the universe. And with each discovery, we are reminded of how much we still don't know. The universe is vast, mysterious, and full of surprises, and the study of ORCs is just one example of the many cosmic phenomena that are waiting to be explored. It is through these mysteries that we continue to uncover the secrets of the universe, one discovery at a time. As we continue to peel back the layers of cosmic mysteries like odd radio circles, ORCs, one thing becomes clear: space is not a silent, empty void, but rather a dynamic, ever-evolving environment, brimming with activity. These seemingly inexplicable phenomena are a testament to the complexity and depth of the universe. ORCs are merely one of the many enigmas that remind us how much we have yet to learn about the forces that shape the cosmos. The fact that ORCs are so elusive and hard to study highlights one of the most fundamental challenges of modern astronomy: the limitations of current observational technologies. Despite advancements in radio astronomy, ORCs remain difficult to observe in high detail. The delicate, faint radio signals they emit are scattered across immense distances, making them challenging to detect and analyze. This means that only the most advanced, sensitive radio telescopes can capture enough data to study them in depth. Instruments like the Very Large Array, VLA, and the Australian Square Kilometre Array Pathfinder, SCAP, have been instrumental in detecting these mysterious circles, but the work is far from finished. Astronomers are continuing to develop new ways to study ORCs, with the hope of unraveling the full story behind them. One of the keys to understanding ORCs could lie in studying their interactions with other cosmic structures, such as galaxies, black holes, and supernovae. By examining how these radio circles behave in relation to nearby objects, scientists may be able to glean important clues about their origins. Could ORCs be tied to the powerful radiation emitted by black holes, or could they be the remnants of long-forgotten cosmic events? As more data is gathered, we may be able to answer these questions and uncover the true nature of these extraordinary structures. Another area of research that could shed light on the mystery of ORCs is the study of their frequency and distribution across the universe. So far, ORCs have been detected in various locations, but they are still relatively rare, and their exact distribution remains unclear. Are ORCs scattered evenly across space, or do they appear more frequently in certain regions of the universe? By mapping their locations and studying the environments in which they form, astronomers could begin to identify patterns that may help to explain their formation. These patterns could reveal insights into the larger-scale structure of the universe, helping us to better understand how galaxies, clusters of galaxies, and other cosmic entities interact. Interestingly, the study of ORCs may also lead to new discoveries about the fundamental properties of space itself. Some researchers have speculated that ORCs could be linked to phenomena like cosmic inflation, the rapid expansion of the universe just after the Big Bang. If this theory proves correct, it would suggest that ORCs are somehow connected to the earliest moments of the universe's evolution. This would provide valuable information about the forces that shaped the cosmos in its infancy, and help us understand the origins of the structures we see today. In addition to their potential connection to cosmic inflation, ORCs could also hold the key to understanding other mysterious phenomena in space. One area of particular interest is the role that dark matter and dark energy play in shaping the universe. These elusive substances have long been a source of intrigue for scientists, and their existence is supported by indirect evidence, such as the gravitational effects they have on visible matter. Could ORCs be linked to dark matter? Could they provide clues about the behavior of dark energy, which is thought to be responsible for the accelerated expansion of the universe? These are some of the pressing questions that scientists are working to answer, and ORCs could hold valuable insights into the nature of these mysterious forces. The discovery of ORCs has sparked an exciting new wave of research, not only into the nature of these radio circles but also into the broader mysteries of the universe. As astronomers continue to observe and study ORCs, they are likely to uncover new phenomena that challenge our current understanding of space. This ongoing process of discovery is a reminder of the vastness and complexity of the cosmos, and how much we have yet to learn about the universe in which we live. In the coming years, technological advancements in radio astronomy are expected to revolutionize our understanding of ORCs. Next-generation telescopes, like the Square Kilometre Array, SKA, and the Next Generation Very Large Telescope, VLT, are set to dramatically increase our ability to observe faint, distant radio sources. These instruments will allow scientists to study ORCs in far greater detail, potentially revealing new aspects of their structure, behavior, and origins. Additionally, advances in data processing and computational modeling will enable astronomers to simulate and analyze cosmic phenomena in ways that were previously impossible. This will help to speed up the process of identifying the causes of ORCs and other cosmic mysteries. The scientific community's growing interest in ORCs is a testament to the power of collaboration and innovation in the field of astronomy. Researchers from all over the world are working together, pooling their knowledge and resources to tackle the toughest questions in space science. Whether it's building the next generation radio telescopes or developing new theoretical models, this collective effort is driving us closer to understanding the nature of ORCs and their place in the broader cosmic landscape. As we move forward, the study of ORCs will undoubtedly lead to even more questions, each one more profound than the last. What role do these radio circles play in the larger context of the universe's evolution? How do they interact with other cosmic phenomena? Could they be a sign of something much larger and more complex than we currently understand? The answers to these questions will not only deepen our knowledge of ORCs but also expand our understanding of the universe itself. Ultimately, the mystery of odd radio circles is just one chapter in the ongoing story of cosmic discovery. As we uncover the secrets of ORCs, we are also uncovering the hidden layers of the universe, layers that challenge our assumptions and push the boundaries of what we thought was possible. Whether we are studying distant galaxies, unraveling the mysteries of black holes, or delving into the nature of dark matter, each discovery brings us closer to understanding the fundamental forces that shape our universe. The universe is full of mysteries, and ORCs are just one of many that remain unsolved. But as our tools and techniques improve, and as our understanding of the cosmos deepens, we may soon find that these enigmatic radio circles are far more than just an oddity. They may hold the key to some of the greatest mysteries of space, offering new insights into the formation of galaxies, the behavior of dark matter, and the very nature of the universe itself. As we continue to explore the cosmos, one thing is certain: the story of odd radio circles is far from over. With each new discovery, we move one step closer to unlocking the secrets of these strange cosmic structures and, by extension, the secrets of the universe itself. The continued exploration of odd radio circles, ORCs, is exciting not just for its potential to answer existing questions but also for the new questions it will undoubtedly raise. These cosmic phenomena, though relatively newly discovered, have opened a portal into unexplored realms of space science, where each new observation brings us closer to a deeper understanding of the universe's vastness and complexity. The mystery of ORCs extends far beyond the radio signals they emit. Their very nature challenges conventional ideas of how objects in space behave and interact. Theories around ORCs are still largely speculative. Some scientists have proposed that they might be the result of active galactic nuclei, AGN, the supermassive black holes found at the center of galaxies that emit intense radiation. AGNs can create high-energy outflows, which might lead to the formation of radio rings. This explanation offers a potential link between these circles and black holes, which are known to play a central role in the evolution of galaxies. However, the lack of definitive evidence makes it difficult to fully accept or reject this hypothesis. Another intriguing theory is that ORCs could be the remnants of supernova explosions. When a star dies in a massive explosion, it sends shockwaves through the surrounding space, creating ripples in the fabric of space-time. These ripples could potentially take the form of radio waves, leading to the formation of circular structures. This would suggest that ORCs might be the aftermath of some of the most violent events in the universe, offering a glimpse into the destructive power of stellar death. However, supernova remnants typically show up as diffuse, irregular radio emissions rather than well-defined circular shapes. This discrepancy makes this theory less likely but does not rule it out entirely. On the other hand, some researchers have proposed a connection between ORCs and more exotic, theoretical concepts like dark matter and dark energy. Dark matter, which does not interact with light but has mass and gravity, could influence the way these radio circles form. Similarly, dark energy, The mysterious force believed to be responsible for the accelerating expansion of the universe could also play a role in shaping ORCs. While these ideas are still in their infancy, they open up fascinating possibilities for future research. Could ORCs be manifestations of phenomena we do not yet fully understand? As we continue to probe deeper into the mysteries of dark matter and dark energy, these seemingly unrelated cosmic structures might offer important clues. The fact that ORCs are found in distant corners of the universe adds another layer of intrigue to the mystery. These structures are not just local oddities but appear to be scattered across vast expanses of space, suggesting that whatever causes them is a widespread phenomenon. They are not confined to any particular region of the sky, nor are they associated with specific types of galaxies or cosmic environments. This raises the question of whether ORCs are a common occurrence, one that simply hasn't been noticed before due to the limitations of our observational technology. It's possible that as telescopes improve and our understanding of the universe grows, more ORCs will be discovered, and their distribution will begin to reveal new insights about the universe's structure. The fact that we are still in the early stages of studying ORCs only makes them more captivating. The discovery of these phenomena speaks to the continuing evolution of space exploration. We are learning more about the universe every day, but many mysteries remain, ORCs included. As scientists and astronomers collect more data, they are refining their techniques, improving their understanding, and testing new hypotheses about the nature of ORCs. It's also important to consider the technological advancements that have made the study of ORCs possible. The development of next-generation radio telescopes, such as the Square Kilometre Array (SKA), promises to revolutionize our ability to study distant cosmic phenomena in unprecedented detail. The SKA, which will be the largest and most powerful radio telescope ever built, will allow astronomers to observe objects that are billions of light-years away with incredible clarity. With such advanced instruments at their disposal, scientists will be able to detect even fainter radio signals, enabling them to study ORCs in greater detail than ever before. Theoretical models will also continue to play a crucial role in advancing our understanding of ORCs. As astronomers gather more observational data, they will be able to test their models and refine their predictions. These models will not only help explain ORCs but also contribute to a broader understanding of cosmic phenomena such as galaxy formation, the behavior of black holes, and the nature of the intergalactic medium. The interplay between observational data and theoretical models is essential to solving the puzzle of ORCs, and the more data we have, the closer we get to unlocking their secrets. While the discovery of odd radio circles is an exciting development in the field of space science, it's also a reminder of how much we have yet to understand about the universe. Every new discovery in space raises more questions than it answers. For every mystery solved, new mysteries emerge. And that is what makes the study of space so endlessly fascinating. The work done by astronomers and astrophysicists is far from over. They will continue to gather data, refine their models, and test new hypotheses. With each new breakthrough, we move closer to understanding the true nature of ORCs and the forces that govern the cosmos. It may be that ORCs are just the tip of the iceberg, and as our observational tools improve, we will uncover even more strange and wondrous phenomena lurking in the depths of space. In many ways, the discovery of odd radio circles serves as a reminder that the universe is far from fully understood. Despite centuries of exploration, we are still only scratching the surface of what lies beyond our planet. New discoveries, like ORCs, remind us that space is a vast, mysterious frontier, and there is always more to learn. As we continue to explore the cosmos, we will undoubtedly encounter more strange and unexpected phenomena. Some may be easily explained, while others, like ORCs, will remain elusive for years to come. But that's the beauty of space exploration. It's a journey that never truly ends. With each new discovery, we expand the boundaries of human knowledge and get one step closer to understanding the infinite mysteries of the universe. So, as we look up at the stars and contemplate the mysteries of the cosmos, we can take solace in the fact that there is always something new to discover. Whether it's a bizarre radio circle or the hidden secrets of distant galaxies, the universe is full of surprises. And as long as we continue to explore, we will never stop uncovering its many mysteries. Continuing from the mysteries of odd radio circles, we delve deeper into the ongoing search for answers and how these phenomena could reshape our understanding of the universe. Despite being discovered only in recent years, ORCs have already sparked intense curiosity among astronomers and physicists, and much of the excitement surrounding them lies in their sheer uniqueness. These ring-like structures are something that no one expected to find, which is part of the reason why they are so captivating. As we continue to observe ORCs with more advanced telescopes and equipment, their study will undoubtedly raise more profound questions about the nature of cosmic events and how galaxies evolve. While theories like black hole activity or remnants of supernovae provide possible explanations, the truth could be even more bizarre or unexpected. Could these ORCs be the result of phenomena not yet fully understood by modern science? It's entirely possible, and that's what makes them so enticing to researchers. One of the challenges in studying ORCs is the lack of a clear and consistent pattern. Not all ORCs appear the same, some are more diffuse and faint, while others are more distinct and sharply defined. This variability in appearance complicates our ability to pin down their origins. It's like staring at a puzzle with pieces that don't quite fit together, but the more we look, the more connections begin to emerge. The diversity of their forms may suggest that there is more than one mechanism responsible for their creation, and as we gather more observational data, we might discover a variety of factors that contribute to the phenomenon. For instance, in addition to black holes and supernovae, cosmic winds, the magnetic fields of galaxies, and even collisions between galaxy clusters could play a role in the formation of ORCs. Interestingly, ORCs could offer a glimpse into the fundamental structure of the universe. In recent years, scientists have been investigating the possibility that the large-scale structure of the universe, including galaxies, clusters of galaxies, and cosmic filaments, might be influenced by previously unknown forces or processes. ORCs might be one of the key pieces of evidence that could point toward new cosmic phenomena, challenging or even expanding existing theories about space and time. Some scientists have proposed that ORCs could be linked to the concept of cosmic inflation, which refers to the rapid expansion of the universe immediately after the Big Bang. This theory suggests that the early universe may have been a chaotic, turbulent place, with energetic outflows and ripples of all kinds, some of which could have left lasting traces in the form of ORCs. The role of magnetic fields in the creation of ORCs is another important area of research. Magnetic fields play a significant role in the behavior of charged particles in space, and they are known to be involved in a variety of cosmic processes, from the formation of stars to the behavior of black holes. It is possible that magnetic fields associated with galaxies or other cosmic structures are responsible for shaping the radio emissions that form the circular patterns observed in ORCs. Understanding how magnetic fields work on such a grand scale could provide new insights into the nature of cosmic forces. In addition to their scientific value, ORCs also raise important philosophical and conceptual questions about the universe. The discovery of such a bizarre phenomenon forces us to confront the limitations of our current understanding. Are we truly grasping the full extent of the universe's complexity, or are we still seeing it through a very narrow lens? It's easy to assume that we understand the basic structure of the cosmos, but discoveries like ORCs challenge that assumption, reminding us that there are still many unknowns. The more we learn, the more we realize how little we actually know. The hunt for ORCs is not just about answering questions. It's also about pushing the boundaries of human knowledge. It's about expanding our understanding of what's possible and exploring new, uncharted territories. Just as the discovery of radio waves decades ago opened up new frontiers in space exploration, so too might the study of ORCs lead to new and unexpected breakthroughs. As we study these phenomena, we are also learning to think differently about space itself, developing new tools, and refining our techniques in ways that will likely lead to further revelations. One of the reasons ORCs are so fascinating is their potential connection to the most fundamental aspects of the universe. They might be providing us with a snapshot of cosmic processes that are happening on an incredibly large scale. In a way, ORCs might be like cosmic fingerprints, left behind by the immense forces at work in the universe, waiting for us to decode their meaning. Just as the fingerprint of a criminal might reveal something crucial about a crime, the discovery of ORCs might provide a clue that leads us to a deeper understanding of the universe's most profound mysteries. As we continue to search for more ORCs and learn more about their properties, we may also find new ways to apply our discoveries. The study of radio waves and cosmic phenomena has already led to advances in technology, from satellite communication systems to medical imaging techniques. By understanding how ORCs interact with radio waves, we might develop new tools and methods that have practical applications in a variety of fields. Science, after all, is not just about understanding the universe. It's also about using that understanding to improve our lives here on Earth. At the same time, the search for ORCs serves as a reminder of the vastness of the universe. No matter how much we learn, there is always more to discover. The more we understand the universe, the more we realize how much we still don't know. It's a humbling thought, but it's also what makes space exploration so exciting. Every discovery, every new puzzle, brings us closer to understanding the true nature of the cosmos. The future of ORC research is bright. As our telescopes become more powerful and our understanding of cosmic phenomena deepens, we will no doubt uncover more secrets hidden in these mysterious structures. It may take years, or even decades, to fully understand what these rings of radio emissions represent, but the pursuit of knowledge is a never-ending journey. And who knows? Perhaps one day we will find that the odd radio circles are just one small piece of a much larger cosmic mystery, one that stretches far beyond what we can even imagine today. As the mystery of odd radio circles, ORCs, continues to unfold, the global scientific community remains eager to learn more about these enigmatic cosmic structures. The discovery of ORCs is still in its early stages, and while much has been speculated, concrete answers remain elusive. The study of these phenomena is complex, requiring both observational data and theoretical models to even begin to make sense of their origins. Each new finding presents more questions than answers, keeping scientists on their toes. But this uncertainty is part of what makes the pursuit so exciting. It's as if humanity has stumbled upon a new chapter in the cosmic story, and we're only beginning to turn the pages. To understand just how profound these discoveries are, it's important to recognize that our knowledge of space is constantly evolving. Space itself is an ever-changing, dynamic environment, and we have only begun to scratch the surface of what we truly know about the universe. New phenomena like ORCs challenge everything we thought we knew about radio emissions, cosmic structure, and the very nature of space. While many space phenomena are well known and widely studied, ORCs are fundamentally different, largely because they represent an unknown form of cosmic behavior. They don't fit into the existing models and expectations of astronomers and astrophysicists. As a result, their discovery has the potential to radically alter our understanding of the universe's structure. There are several intriguing avenues of research being pursued to shed light on the mystery of ORCs. One of the most promising areas of investigation involves the study of cosmic radio waves. Radio astronomy, which involves the detection of radio waves from space, is already an essential tool for scientists exploring the cosmos. But ORCs represent a new and unexplained aspect of these emissions, which could open up entirely new fields of research. For instance, radio waves can provide information about the density and composition of the objects they pass through. As scientists analyze ORCs, they may uncover new insights into the distribution of matter in the universe, particularly in areas that were previously thought to be devoid of significant structures. Another critical factor in the study of ORCs is the role of gravitational waves. These ripples in space-time, first predicted by Albert Einstein, have been confirmed to exist in recent years. Gravitational waves provide an entirely different way of observing the universe, allowing scientists to study cosmic events that are otherwise invisible to traditional telescopes. Some scientists have suggested that ORCs could be the result of gravitational waves emanating from massive cosmic events, such as black hole mergers or the collapse of massive stars. While this is still a speculative theory, it highlights the potential connection between ORCs and some of the most extreme and powerful phenomena in the universe. The potential link between ORCs and black holes is another area of active exploration. Black holes, the mysterious and incredibly dense objects that warp space-time, are already known to emit powerful radio waves. The idea that an ORC could be the result of a black hole's activity is particularly intriguing, as it could provide scientists with new ways to study these elusive objects. For example, the magnetic fields surrounding black holes could be responsible for creating the ring-like shapes that define ORCs. If this theory is correct, ORCs could provide valuable insight into the behavior of black holes and the forces at play in their vicinity. But the most captivating possibility about ORCs is that they could represent something entirely new. Something not yet conceived or understood by modern science. There's always a chance that these cosmic rings are part of a process or phenomenon that is entirely foreign to our current theories of physics. Could ORCs be the signature of a previously unknown type of cosmic event, or an entirely new form of energy? The idea that ORCs could be the result of something that fundamentally shifts our understanding of the cosmos is one of the most exciting possibilities. It's a reminder that the universe is vast, and we are only beginning to scratch the surface. While much of the research into ORCs is still in its early stages, there are already significant technological advancements being made to aid in their discovery and analysis. Modern radio telescopes, such as the Very Large Array, VLA, and the Square Kilometre Array, SKA, are being used to observe ORCs and other cosmic radio emissions. These advanced instruments are capable of detecting faint signals from deep space, allowing scientists to observe phenomena that were previously beyond our reach. With these tools, scientists can study the physical characteristics of ORCs, such as their size, shape, and composition. This data is crucial in helping to narrow down the possible causes and origins of these structures. As technology continues to improve, we can expect even more detailed observations of ORCs and other cosmic phenomena. Upcoming space missions, such as the James Webb Space Telescope, are poised to provide even more data about the deep universe, including the regions where ORCs are most likely to be found. The ability to observe space in more wavelengths, from infrared to X-rays, will allow scientists to create more comprehensive models of the universe and refine their understanding of strange phenomena like ORCs. These breakthroughs will not only help scientists answer the questions raised by ORCs but will also open up entirely new areas of study, deepening our knowledge of the cosmos. As we look to the future, the mystery of ORCs will continue to capture the imagination of scientists and the public alike. It's a reminder of just how much we still don't know about the universe. Every time we think we have a handle on the vastness of space, a new discovery challenges us to rethink our assumptions and explore the unknown. And that's what makes the study of space so exciting, the constant quest for knowledge and the endless possibility of discovery. With ORCs, we have a glimpse into a universe that is far more complex and mysterious than we could ever have imagined. It's a puzzle that scientists are eager to solve, and with each new discovery, we move one step closer to uncovering the true nature of the cosmos. As we continue to explore and understand ORCs, it's important to remember that space is an incredibly dynamic environment. These radio circles, like other cosmic phenomena, are part of an ever-changing universe that's constantly shifting and evolving. By studying these mysterious structures, we not only learn more about the universe itself but also gain insight into the forces and processes that shape our own existence. The study of ORCs is just one chapter in the ongoing story of our understanding of the universe, a story that will continue to unfold for generations to come. What makes ORCs particularly fascinating is how they challenge our understanding of the universe's structure and dynamics. While most cosmic phenomena, such as galaxies and stars, can be studied within the framework of current scientific theories, ORCs force us to reconsider what we know. Whether they turn out to be the result of black holes, gravitational waves, or some entirely new process, their discovery serves as a reminder of the vastness of the cosmos and the many mysteries still waiting to be unlocked. As more ORCs are discovered and studied, the picture of the universe continues to grow ever more complex. The answers may not come easily, But the journey to understand these strange cosmic rings will undoubtedly lead to groundbreaking discoveries and insights. And along the way, we'll continue to explore the outer limits of human knowledge, pushing the boundaries of science and our understanding of the universe itself. The intriguing nature of odd radio circles, ORCs, forces us to confront our current understanding of the universe and the very laws of physics that govern it. One of the most profound aspects of ORCs is how they appear to transcend the boundaries of conventional cosmic structures. In the vastness of space, we've come to expect certain types of objects, galaxies, stars, nebulae, black holes, all of which can be studied using established methods. However, the ring-like formations of ORCs present a unique challenge. They do not fit neatly into these categories, and this forces us to reconsider what we know about radio emissions, cosmic matter, and even the structure of spacetime itself. One possible explanation that has been suggested in relation to ORCs is the phenomenon of shockwaves in space. Much like how shockwaves propagate through the air during an explosion, there's the possibility that the ORCs could be the result of shockwaves originating from highly energetic events in the universe. These shockwaves could travel through space, creating ripples that manifest as the distinct circular patterns that we observe as ORCs. The source of these shockwaves could vary from the collision of massive celestial objects, such as neutron stars or black holes, to the outburst of energy from a supernova or some other explosive event in the universe. This idea is not entirely far-fetched, given that shockwaves are observed in various environments on Earth and throughout the universe. The shockwaves produced by supernovae, for example, are some of the most powerful explosions known to science. These events send out ripples of energy that spread across space, and it is conceivable that similar shockwaves could give rise to the ring-like structures that define ORCs. However, even if this hypothesis holds some merit, it does not fully explain the uniqueness of ORCs. The radio emissions associated with ORCs are unlike the emissions typically seen from other shockwave-related phenomena in space. The patterns they produce seem almost deliberately structured, suggesting that there may be some other process at work. One of the ongoing challenges in studying ORCs is the lack of concrete observational data. Though a number of these radio circles have been discovered, they remain elusive in many ways. The vastness of space, combined with the limitations of current technology, means that scientists are only able to capture brief glimpses of ORCs, often without sufficient context to understand their full nature. For example, the first ORC was detected using the Australian Square Kilometre Array Pathfinder, a SCAP, a powerful radio telescope. While a SCAP's sensitivity allowed for the detection of these phenomena, further study is required to fully map and understand them. With each new discovery, scientists gather more data, but much of the data is still inconclusive, leaving many questions unanswered. To resolve these mysteries, astronomers are turning to increasingly sophisticated observational techniques. Next-generation radio telescopes, like the Square Kilometre Array (SKA), are expected to provide far more detailed images of ORCs and other cosmic phenomena. These advancements will be crucial for uncovering the true nature of these structures. The SKA, for instance, will be the world's largest radio telescope, with the ability to capture images of the universe at unprecedented levels of detail. It's hoped that such advancements in technology will allow scientists to study ORCs in greater depth and, ultimately, reveal the true origins of these cosmic anomalies. The potential for ORCs to help scientists uncover new insights into the fundamental nature of the universe cannot be overstated. Some experts believe that ORCs may serve as a key to unlocking the mysteries of dark matter and dark energy, two of the most elusive and poorly understood components of the cosmos. Dark matter, which makes up around 27% of the universe, cannot be seen directly, yet its presence is inferred from its gravitational effects on visible matter. Dark energy, an even more enigmatic force, is believed to be responsible for the accelerated expansion of the universe. The discovery of ORCs could help provide clues to the behavior of dark matter and dark energy, and this would mark a monumental leap forward in our understanding of the universe. However, one of the most fascinating possibilities is that ORCs may offer a glimpse into entirely new physical processes. These enigmatic radio circles could be the result of mechanisms that we have yet to discover, potentially revealing new forces or forms of energy that have never been seen before. This is where things get really exciting, as it opens up the potential for entirely new branches of physics to emerge. It's a reminder that space, with all of its complexities and mysteries, is not just a realm for the curious and the adventurous, but also a place where science is constantly being pushed forward by the pursuit of the unknown. In a sense, the study of ORCs is akin to peering into the very fabric of the universe itself. Each new discovery presents both a challenge and an opportunity. The more scientists learn about ORCs, the more they realize just how much remains to be understood. The mysteries of the universe are not finite, rather, they are an ever-expanding frontier. ORCs are just one of many enigmatic phenomena waiting to be explored, and with each discovery, the scientific community inches closer to unraveling the grand cosmic puzzle. As the study of ORCs progresses, there's also a philosophical element to consider. The discovery of a new cosmic phenomenon often forces us to rethink our place in the universe. It challenges our understanding of the laws that govern space, time, and energy. Every time we encounter something that defies our expectations, it reminds us that our knowledge of the cosmos is still incomplete. There's a certain humbling quality to this. It's a reminder that, despite our advancements, the universe is far more complex and mysterious than we could have ever imagined. And as we explore these mysteries, we may begin to realize that the universe has far more to teach us than we could ever hope to learn in a single lifetime. The discovery of odd radio circles is just the latest example of how the universe continually surprises us. It serves as a testament to the limitless potential of human curiosity and the unyielding drive to explore the unknown. As scientists continue to investigate these strange radio structures, they will undoubtedly uncover new and exciting insights that will push the boundaries of our understanding even further. And who knows? Perhaps one day, the mystery of the ORCs will be solved, and they will become yet another piece in the grand cosmic puzzle, a puzzle that, despite its complexities, continues to inspire awe and wonder in all who dare to explore its depths. The pursuit of understanding odd radio circles, ORCs, not only offers the potential for significant scientific breakthroughs, but it also touches on the deeper questions that have always been at the heart of human curiosity. What is the true nature of space? What drives the forces at play in the universe that we still don't fully comprehend? ORCs, in their elusive and enigmatic nature, remind us how much we still don't know, despite centuries of scientific progress. But just as the mystery of ORCs seems impossible to unravel, it may very well be that the key to unlocking it lies in the pursuit of ever deeper knowledge. One possible avenue for studying these cosmic rings lies in the way radio waves interact with the surrounding space. Radio waves, which are electromagnetic waves, are known to be incredibly sensitive to changes in their environment. A small disturbance, such as a shift in gravitational pull or the collision of two massive cosmic objects, can cause a ripple in the radio emissions that can be detected here on Earth. The unique patterns observed in ORCs may, in fact, be the result of such disturbances, but with origins that are still beyond our grasp. To fully understand ORCs, astronomers must explore how these radio waves are affected by the vast reaches of space they travel through and how they are influenced by the objects they encounter along the way. The interplay between the radio waves and the surrounding cosmic environment opens up another intriguing avenue of study: the role of magnetic fields in the creation and propagation of ORCs. Magnetic fields are known to play a central role in the behavior of plasma, the hot, electrically charged gas that makes up much of the visible universe. Plasma is found in stars, interstellar gas clouds, and even in the space between galaxies. The radio emissions from ORCs may be influenced by the magnetic fields in the regions where these rings are found. These fields could bend and twist the radio waves, distorting them in ways that create the characteristic circular patterns we observe. This magnetic influence could be more than just an interesting quirk of cosmic physics. It could be a clue to the origin of ORCs. In some areas of space, such as near black holes or neutron stars, magnetic fields can become incredibly strong, creating conditions that allow for unusual phenomena like the formation of highly energetic plasma jets or bursts of radiation. If ORCs are indeed the result of magnetic fields interacting with plasma, they could represent a new type of cosmic structure that we have never observed before. This would have profound implications for our understanding of both magnetic fields in space and the behavior of plasma under extreme conditions. Yet, as with most mysteries in the universe, there's the possibility that ORCs aren't the result of any physical or astronomical process that we already know. Instead, they could be the product of a phenomenon that defies all current explanations, a mystery that forces us to rethink everything we thought we knew about space. Perhaps ORCs represent an entirely new form of cosmic phenomenon, one that doesn't fit into any of the existing categories of stars, galaxies, or black holes. In this scenario, the ORCs could be the first of many such discoveries, offering a glimpse into a new realm of the universe that has remained hidden from us until now. To explore this possibility further, scientists would need to take into account the incredible variety of cosmic phenomena that exist in space. Space is a vast and varied environment, and the objects we observe can behave in ways that we often don't expect. Some of the most mysterious objects in space, such as fast radio bursts, FRBs, and gravitational waves, have forced scientists to rethink how we study and understand the cosmos. The discovery of ORCs could very well be another step along this journey of unearthing the unknown. Like other cosmic anomalies, ORCs may hold the key to understanding deeper mysteries of the universe, and this knowledge could ultimately lead us to the next great leap in science. At the same time, the discovery of ORCs challenges our understanding of how the universe is structured. Cosmic objects like stars and galaxies are typically arranged in predictable ways. They follow the laws of gravity, and their behavior can be understood through the principles of physics that have been developed over centuries. But ORCs appear to be something entirely different, a phenomenon that doesn't fit into these established models. The very existence of such an anomalous structure suggests that the universe may be more unpredictable and complex than we ever imagined. ORCs, then, represent not only an unsolved puzzle in their own right but also a reminder that we have only just begun to scratch the surface of understanding the true nature of the cosmos. As we continue to study these strange radio circles, we must also consider the broader implications of their discovery. While ORCs are fascinating on their own, they also represent a larger question: how much of the universe remains hidden from our current understanding? Every time we encounter a new cosmic mystery, we are forced to confront the limitations of our knowledge. The universe, after all, is vast and ever-changing. New discoveries are made every day, and each one pushes the boundaries of what we think we know about the cosmos. In many ways, the study of ORCs is just one part of this larger quest to understand the universe. The discovery of new phenomena, whether they're cosmic rings, strange radio bursts, or entirely new forms of energy, only deepens the sense of wonder and excitement that comes with exploring the cosmos. It's a reminder that we are far from finished in our quest to understand the universe. If anything, ORCs are just the beginning of a new chapter in this ongoing exploration. As we look forward to the future of space exploration and research, one thing is certain: ORCs will continue to be a topic of great interest and intrigue. Whether they are the result of shockwaves, magnetic fields, or an entirely new cosmic phenomenon, they represent a challenge to our current understanding of the universe. They are a call to action for scientists, astronomers, and curious minds everywhere to keep pushing forward, to keep questioning, and to keep seeking out the answers to the mysteries that lie beyond our reach. Odd radio circles are one of the most mysterious and exciting discoveries in modern astronomy. Though we have made significant progress in understanding the universe, phenomena like ORCs show us just how much we still have to learn. They push the boundaries of what we think we know about space, energy, and cosmic matter, and they offer a glimpse into the vast unknown. The study of ORCs could one day reveal new insights into the most fundamental questions about the universe, from dark matter and dark energy to the behavior of cosmic magnetic fields. As we continue to explore these strange radio rings, we are reminded that the universe is far more mysterious and complex than we can ever fully comprehend. And that's what makes it so endlessly fascinating. As we delve further into the complexities of odd radio circles, ORCs, it's clear that these anomalies hold the potential to transform our understanding of the cosmos. Despite being discovered relatively recently, ORCs have already sparked a wave of scientific curiosity. However, what truly sets these objects apart is the fact that their origins and exact nature remain elusive. They are not just another cosmic oddity to catalog, but rather an invitation to rethink many of the established theories that have guided our understanding of the universe. One of the most intriguing aspects of ORCs is their size. These structures can span hundreds of thousands of light-years across. To put that in perspective, that's many times larger than even our own Milky Way galaxy. This immense scale suggests that whatever is creating these rings must be a powerful and far-reaching cosmic force. Whether they are the result of shock waves propagating through space, magnetic fields, or something more exotic, the sheer size of ORCs makes them a cosmic enigma that defies easy explanation. Moreover, their ring-like structure adds another layer of mystery. Unlike other known phenomena in space, there is something particularly strange about a perfect, circular structure of radio emissions emanating from a specific region of space. This suggests that ORCs may not be isolated events but part of a larger, more intricate process occurring in deep space. As scientists continue to explore ORCs, they are forced to confront one of the biggest questions in modern astronomy. Could these structures be the result of previously unknown forces or phenomena? As we peer deeper into the cosmos with increasingly advanced technology, we are constantly faced with new discoveries that challenge the foundations of our knowledge. This is not unusual, of course. Science progresses precisely by questioning existing theories and pushing the boundaries of what we know. However, ORCs present a particularly striking challenge because their existence seems to defy categorization. Astronomers are still unsure if these radio circles are the result of natural phenomena, or if they represent something even stranger and more fundamental to the workings of the universe. To better understand ORCs, astronomers are turning to various tools and methods to analyze these cosmic structures. High-resolution radio telescopes, like the Australian Square Kilometre Array Pathfinder, a SCAP, have been instrumental in detecting and studying ORCs. These telescopes allow scientists to capture incredibly detailed images of the radio waves emitted by distant objects in space. By examining these signals, astronomers hope to determine the precise location and characteristics of ORCs, as well as the nature of the forces driving their formation. So far, however, no one theory has been able to fully account for the data collected. Some researchers speculate that ORCs could be the result of interactions between large-scale cosmic jets or shock waves traveling through the intergalactic medium, while others suggest that they may be linked to the behavior of supermassive black holes at the centers of distant galaxies. However, the debate remains ongoing, and the true cause of these structures remains one of the great mysteries of modern astronomy. The lack of a definitive explanation for ORCs has led to various hypotheses, some of which are more grounded in established science than others. One possibility is that ORCs are the result of interactions between cosmic jets, streams of high-energy particles and electromagnetic radiation emitted by supermassive black holes. These jets can extend across vast distances, and it's possible that the radio waves emanating from the center of these jets could form a ring-like pattern as they propagate through space. In this scenario, the ORCs would essentially be the result of these jets interacting with the surrounding interstellar medium, creating shockwaves that shape the radio emissions into circular structures. This hypothesis would explain the large scale and symmetry of the ORCs, as well as their apparent alignment with the galactic plane. Another possibility is that the ORCs could be the result of the movement of gas and plasma in galaxy clusters. When massive galaxies collide or interact, they can stir up the surrounding gas and plasma, creating shock waves that propagate through the region. These shock waves could potentially create concentric rings of radio emissions, which would appear as ORCs. This theory suggests that ORCs might be tied to the larger-scale structure of the universe, and could provide valuable insight into the dynamics of galaxy clusters and the forces at play in these enormous cosmic environments. This idea is consistent with the fact that many of the ORCs detected so far appear to be located near galaxy clusters, further supporting the notion that they may be linked to these large-scale cosmic structures. A third hypothesis posits that ORCs could be the result of a previously unknown form of cosmic energy, or radiation. Perhaps these mysterious rings are not the product of known forces such as shockwaves or magnetic fields, but are instead the result of some entirely new phenomenon that we have yet to discover. This could involve exotic particles or forms of energy that behave in ways we don't yet fully understand. It's also possible that ORCs could be tied to dark matter or dark energy, the mysterious substances that make up most of the mass and energy in the universe but remain largely undetectable through conventional means. If ORCs are indeed linked to these elusive forces, they could provide a breakthrough in our understanding of some of the most fundamental mysteries in modern physics. While each of these hypotheses offers a plausible explanation for the origins of ORCs, none have been conclusively proven. This is the nature of scientific discovery. Theories must be rigorously tested and challenged before they can be accepted as fact. In the case of ORCs, the data we have so far is still too limited to draw definitive conclusions. However, the fact that astronomers are even able to detect and study these cosmic structures is a testament to the incredible progress we have made in our ability to explore the farthest reaches of the universe. As we look ahead, it's clear that the study of ORCs will continue to be a major focus of research in the coming years. Advances in technology, such as the next generation of radio telescopes and the development of new methods for analyzing cosmic data, will allow scientists to probe even deeper into the mysteries of space. As our understanding of these strange radio structures grows, we may find that they hold the key to answering some of the most profound questions about the universe. What is the nature of dark matter? How do cosmic jets interact with the intergalactic medium? What drives the behavior of massive black holes at the centers of galaxies? Perhaps, as with many other great scientific discoveries, the true nature of odd radio circles will only be revealed as we develop new tools and techniques that allow us to peer deeper into the cosmos. In the meantime, these mysterious structures serve as a powerful reminder of how much we have yet to learn. Each new discovery brings with it a sense of wonder and excitement, and ORCs are no exception. They are a testament to the infinite complexity of the universe, and to the endless possibilities that lie beyond our current understanding. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.